Alright, so two of our favorite things, lead code easy questions and linked lists. We'll be solving a problem called merge to sorted lists. We'll go over a quick description right here. I wonder what this lock sign is for, locked companies, whatever that means. So we are given the heads of two sorted linked lists, list 1 and list 2. What we have to do is merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Splicing, I don't care what that means. And then we return the head of the merged linked list. Here's example 1, where we see our list 1 is 1, 2, and 4. List 2 is 1, 3, and 4. Therefore, our merged linked list should be 1 and 1, and then 2, and then 3, and then 4 and 4. And then example 2, if both nodes, if list is empty, we just return an empty list again. And then if one list is empty, return the second list. I'll say this again because this is important. If both are empty, return an empty linked list. If one at any point get empty, just return the other linked list. Where's my coffee? Here you go. All right. So here's our constraints. The number of nodes in both lists is in the range of a minimum of 0 to a maximum of 50. As per the values, the lowest value is negative 100, the highest value is positive 100. Both lists 1 and list 2 are sorted in non-decreasing order. That just means it's sorted in increasing order. We have submissions, we have a 63% acceptance rate, that's good, and then we have discussions. So here's my code, but before we get into it, just see submissions. This is the code when I submitted 16th of August with a runtime of 3 milliseconds, beating 94.54%, and a memory of 14.8 megabytes, beating 58.95%. So let's go back into description and we'll just do some discussion before we actually begin. Why can't we use concat and sort here? This don't seem like something in C++. Concat and sort. I don't understand the class given above. Can anyone explain? The class is just a solution. So the way this will be run is it'll be a solution. No, it should be list node, and then it'll be solution, and then merge two lists and the parameters. That's how it would probably be called, or they'll just call it directly with a create an object called a solution. So it could be done in the way of let's see, solution sol1, and then just they initialize it and they call sols dot merge two lists with the params. So let's see, that'll create an object. Yep, that'll create an object, and we just call merge two lists. Yep, so that's probably how they're calling it, but I don't know the details yet. So someone please explain the meaning of slicing. Yeah, dude, I also don't care actually. Just start learning algorithm. Here's my question. I'm using the ID to write main and run my code, but I don't know what to input in the solution. I don't read that question. And I almost get annoyed pointing exception. I'm trying to reference val. So yep. Anyway, I'm not going to show the code here because it's quite small. We'll actually go into my code blocks. Here we go. The definition. Okay, let me have coffee again. We have our C++ program called main.cpp and a file called merge linked list. We're using the library IOStream. I'm actually outing any value. Well, that there, but in reality, we don't even need IOStream. I don't think so. There's namespace standard. I also don't think I need that. Except there, but that's just fluff. So yeah, in reality, we don't need any of those two. So definition for a singly linked list. A singly linked list is one in which the link only goes in one direction. It's unidirectional, not bidirectional. Then we have the definition for it. It's called list node, where it has an info called value and an address called next. And then below that, let me just add a comment here. We have our, I swear to God. We have our constructors. our constructors. This is our three constructors. Remember, in the structure, by default, everything is public. In a class, by default, everything is private. Remember that. So if we create a list node and we give it, we just create a list node with no value, the value will be set to 0 and the address will be set to null pointer. If we create a list node with a value of x, value will be set to x and the address will be set to null pointer. If we provided a value and a pointer, so an address, then value will be set to x and next will be set to the address of whatever this address and next was. We then have our class called solution with a public member function called merge two lists, which returns a list node, obviously. It takes as parameter two linked lists, list 1, list 2. Obviously, you can write your function definition in the class. I chose to write it outside the class, but that's just because I'm using code blocking. That's what I'm used to doing. It's not needed. So again, let me just go ahead and add a comment. Solution. Save that. So list node, solution, resolution, scope operator, merge to list, blah, 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 not important. And then we begin. We create a variable of type list node and I call it last small, pointer to the last node of the merged list. The last node of the merged list. Again, pointer to the last node of the merged list. What's the merged list? The one we're creating. Then we have new head. It's a pointer to the merge list. So last node, first node, last node, first node. Let me just go and be specific. Last node, first node. Then we check if either list is empty. If list 1 is equal to null pointer, return list 2. Else if list 2 is equal to null pointer, return list 1. Okay, that's our first case. Great. Neither list is empty, so we come and we do this. Let me just go back there. We go into our else block. What we do is we compare the first pair of nodes. So to go back here, we'll compare 1 and 1, such that x is a node from list 1 and y is a node from list 2. Then we check. If list 1 dot value is less than list 2 value, we will set new head, so the pointer to the first node, to equal to list 1. New head is now pointing to the same list as list 1. So basically, this first list here, new head just points to the first list currently. We then say list 1 advances to the next node. We're advancing list 1, y currently points to the next node. We're not losing anything because currently new head points to the same, to the old list that list 1 pointed to. We set last small equal to new head. So basically, why are we doing this? The first time we do our comparison, the merge list is empty. Therefore, new head and last small should both point to the same node or nodes. Else. So list 1 value is not less than list 2 value. We come in here and we do the same thing, but this time using list 2 values. So new head is equal to list 2. List 2 is equal to list 2. We'll advance it by one node, and we set last small equal to new head. Basically, right now, new head and last small are pointing to the same linked list. That linked list can be made of one node, it can be made of 100 nodes, it does not matter. So, and then we continue to search and compare of the form x, y. Remember, x is a node from list 1 and y is a node from list 2. We'll continue our search until list 1 is not equal, while list 1 is not equal to null pointer and while list 2 is not equal to null pointer. Coffee. We'll then just do, see this logic right here? This right here, all we can do is copy it and paste it there. And then we say last small next. So the last value will now point to list 1. We start connecting our nodes. Last small itself will now point to the last node. Then we say list 1, we advance list 1. Same thing here. So list 1 value is not less than list 2 value. Therefore, last small next, the link will now point to list 2. And then we say last small equals last small next, because now we want the last node to actually point to the last node. Then advance list 2. When I say advance, I mean point to the next one. Once we're done checking everything here, at some point, one of the lists, example here, may be exhausted first. What does it mean? If we have two linked lists, and one is of length 2, one is of length 3, our first linked list of length 2 will be exhausted before the second linked list, because obviously it's less than. At that point, all we have to do is have last small point to the second linked list. Conversely, if list 2 is exhausted first, we'll have last small point to the first linked list. Then we just return new head. And that is it. Seems like a lot, but trust me, if you just read the code here and follow it, it's actually quite simple. Let me go ahead and save everything. I don't know why I'm saving everything. I'm not going to run it here. I'm going to go back here. I'm running just for the sake of running it. And there we go. Everything's working. We'll do a little submit again. And there we go. So that had a runtime of 3 seconds. This 3 milliseconds. This has a runtime of 7 milliseconds. Same exact code. So let's go a little down here. Discussions, anything that I want to answer. I don't answer the class given above. Why can't we use concat and sort here? Please explain the meaning of splicing. I don't only want a very vague requirement. Merging doesn't necessarily mean that they have to be in increasing order, which it seems it's supposed to be. Seriously, write the stuff in the notes so we don't waste time. What do you mean? Merge. So what this dude is saying is, merging doesn't necessarily mean that it be in increasing order. Okay, here's the thing. You are not always going to be given problems that suit you. Things will not always be to your benefit. You just have to work around it, and that's it.